All right, welcome back. Now, on to first floor framing. First floor ceiling, also known as second floor floor. So, there's a bunch of different ways you can do it. This customer specifically asked for stick framing, but there's always the option for I-joist, floor trusses. Um, I-joist floor trusses can span further, but they're usually more expensive. But for really large houses, they're usually the most efficient product. So, but this owner specifically specified stick framing. So for stick frame floors, we typically do 2x10s at 16 inches on center. If 2x10s at 16 inches on center, let's bring up the span chart. So here you go, 2x10, 16 inches on center. Number two, 14 feet is the max span that they can go. You typically don't want for to specify that to 14 feet because obviously the farther it is, the more maxed out it is, the more bouncy it is. You typically don't want a bouncy floor because even if it works structurally, a lot of times the customer will complain saying, why is my floor so bouncy? And why is it sagging so much? It's like, and then you have to explain to them, well, per code, everything still works. It's fine. It's just unpleasant. So typically, once it gets to that level, that's when I'll say, all right, well, let's just move it up to 12 inches on center or 16 inches on center and then have them double every third joist. That's pretty much an equivalent of 12 inches on center because you'll have four members within a 4 foot span, which you divide that and that equals 12 inches on center. So you'll also do that whenever you have a span that needs 12 inches on center, but it's also coming into where the rafters bear. Um, that the reason being that if you have your rafters at 16 inches on center and your floor joists at 12 inches on center, they're not going to align, and then you're going to have problems because sometimes they're going to conflict and you can't put the floor joists where you need them, or you can't put the rafters where you need them. So that's why you always want to make sure that your floor joists and your rafters are at the same spacing. So that's why in that situation, we'll do 2x at 16, double every third joist. So let's get started. First things first, always, always, always track down your loads. Right? Okay. Grab all this, copy it from base point. All right. So remember on the roof plan, whenever I said, "Oh yeah, these are going to be in the first floor walls, so we don't need to call those out right now." Now that we've copied everything down, we're on the first floor. Now we need to specify, what that needs to be. I know these are 9 foot walls. I know from years of experience that 2 stud columns is fine here. However, let's come over here to beam check. You come to columns. You put in what your reaction is. So this is 1607. We come down to dimension lumber, nailed 2x. There you go. Then you put where your column height is, 9 feet. Unbraced, 0. L1 is 0 because on this side, there's going to be either sheathing or drywall on both sides of the wall. So unless it breaks the sheathing and busts out all the drywall to flex that way, it physically can't flex that way. So that's why it's continuously braced about that. So there is no spacing. So it's 0. And then 9 feet is the column height, because basically that's where all that is. Now, if all these were bolted together, then you would just put whatever your bolt spacing is here, because then it would have to bust out the bolts. But if you have nails, then nails aren't as strong as that, so I typically just ignore that altogether. So then we come down here, SPF number 2. There you go. Two 2x4s works at 38%. That goes to show you that technically one stud column will work, but we always minimum 2. Copy that. Since this is actually less than, yeah, it's 956 pounds, so 2 stud columns is fine. Let's see if this is 2,800 pounds. Let's see if that 3 stud column still works from up above. Yeah, 2 works, so 3 definitely works. There you go. All that still works. So here we have all these point loads, these stud columns up above. They're all now resting on these windows. So we'll need to size a header for all that. But we'll get to that later. So right here where we had roof support beam below, now we are in the first floor, so we're at where the below is. We can come out here, change this to a beam, delete that. We'll need to size what that beam is as well. We'll just label this. We just trim those sides. This is just a placeholder right now. I just needed that text right there. So come over here. Let's grab some studs. Grab all that. Copy. All right. So right now, we know that what's on this beam is this roof load here, but we don't know what else is on it yet. So we'll hold off. First things first, let's size our floor joists. So, like I said before, 2x10s at 16 is good for 14 feet. At 12 inches on center, it's 16.2. So, because our rafters run front to back, everywhere except in this area, let's try to do front to back for our floor joists. So, so I think this will be a good wall. 11'6", that's a good span. How about here? 11'2", that's a good span. And then running from there to there, that's 4'2", that's fine. 6'8", that's fine. From here to here, 11'6", that's fine. And then from here to here, 16 feet. So that's a little far, but this area is actually a tray ceiling, so it's trayed up. So what we can do here, what I like to do is actually, I actually like to frame, rather than, because there's 2 ways to frame a tray ceiling. You have beams on either side, and then you put the ceiling joists on top of the beams to box out to make that cavity there. Or what I like to do is actually just have them frame those rafters at whatever height it is. So everywhere else it's 9 feet, except here it's 10 feet. So what I'll have them do is just frame these joists at 10 feet and then frame everywhere else at 9 feet. All right. Okay. So that was 16 feet, remember? So what we'll do is we'll have double every third joist. In fact, let's bring that double every third. And then we'll add frame, tray, ceiling. Wait, frame, joist at tray, ceiling at 10-foot ceiling height. There we go. So that goes to show that pretty much everywhere else they'll just frame it at 9 feet, but frame the joist at the tray ceiling at 10 feet. And since we have another tray ceiling, let's just copy that text over. Let's see what this span is. 15 feet. So yep, that has to be at 12 inches on center too. So here, and then over here, we'll just remove that part because there's not a tray ceiling there. But remember where I said before where this text is being blocked by the wall and you can't really see it? So we'll come over here, come to the properties, text, fill color, change it to background, and now you can easily see the text. Not a problem. All right. So now that wall's there. And then remember, this wall now is being supported right. So you see where this is the wall from up above. This is now a load-bearing wall. How even though everywhere else we're running our joists front to back, this is a load-bearing wall from up above. Sometimes if we didn't do this, a lot of times you'd forget because everything else is running this way. You're like, oh yeah, that's not a load-bearing wall. I don't need to worry about it. But because we did do that, that's one of the many reasons why I like doing that, because it reminds you, it's like, oh yeah, this is load from up above that we need to support. And if you miss it, then and you don't support it properly in the foundation, it can cause a huge problem in the field, a huge problem if it's even missed there later down the road. So, all right, now we've got our biggest spans out of the way. So, let's come back here and put our spans. Right, that one's done. That one's done. Let's just copy them everywhere. The garage is different, so because we'll have to actually size the beams and figure out which way we actually want to run our supports there. So we'll do that later. Now here, we already see that we're going to have a beam. So let's see what this span is. 16 foot 10. So yeah, we can't actually span that. So we're going to need a beam. Right here. As you can see, rather than coming down here and copying that beam or putting it on the floor one beams layer. The quickest way to do everything is just come up here to match properties and draw a line and then just match it to that property. Right. So, a couple of areas that we haven't done yet. So this area, and this area. So let's start with this area here first. So because we're using this as roof support, there's actually going to be a huge knee wall. A knee wall is just basically a shorter wall. It's not a full height wall. It's just a wall that's used either to just block out an area or used for support. In this case, we're using it as support. So because there's a wall that pretty much goes on top of the wall to support the rafters, this area isn't even going to be accessible from the rest of the spot, from everywhere else. So they can't walk over here. So what we'll do is change this loading in this area to 2030, which is just light storage. Because of that, we'll change this to 2x6s. And I'll bring up that chart as well. So ceiling joist, 20 pounds live load, light storage, 2x6s can span 12 feet. Technically, you could probably do 10-15 or 10-20, but because it's the bedroom and it's highly unlikely that they're just going to have random storage in this back 6 feet or so, or back 6'6". So you could do that, but I like to be more cautious or more conservative in these areas. However, this area over the porch, I'll usually do that 10-20 just because it's a porch. No one's going to support anything. No one's going to have any, any storage over a porch. So let's come over here. Let's draw a line for our beam. We just match properties. Then same thing here. Draw a beam. Easiest way is just draw a polyline, which you can, I'll show you how to do that. You can either come up here to line. Well, we'll come over here to polyline and draw it. The polyline is basically makes it so all these lines are connected. If you were to draw this as just a regular line, it would see this as 3 lines. So what you do is you just come here, use your offset command, which is O, and then offset it 2 inches, just so you can be in the center of the wall because the walls are drawn at 4 inches. There you go. And then we can delete that outer one. And then come over here to match properties. And then you can explode it. X. And there you go. Quick and easy. Let me copy this. And there we go. Now you have your beams for your roof. Well, for your porch drawn in. So now we've got our beam. Now, while we're in the in the mode of drawing beams, let's draw our beam for our garage. So the garage is, let's see, let's change this to quick. So from end to end is 21'6" in front to back direction, 21'8" in north to south direction. So it's pretty much the same. However, if you were to run it this way, then you'd have a big beam supporting things, supporting your floor, and it's going to be right in the middle of this header, this beam. So that's worst case scenario. So let's just run our beam this way. So that way it can also line up with the rafters, which are running left to right. So we can That way, if we put our beam here, we can also run it left or right. But there's a landing. Don't forget, on the second floor, the stairs come up here, and the last riser is actually right here. So we have to make sure that we don't interfere with that. So what we'll do is we'll come over here, copy one of these. There we go. Put it right beside it. And then we can run our beam, use our F8 command so we can make sure the line is straight. All right. Now, you can either just select one of those other 2x10 callouts, or just, since this one was already in that direction, just copy that. There you go. All right, and then let's also do our beam for our garage header. Match properties. Mirror it. You could copy it, but I just find that mirroring it is easier because it already brings it there. All right. And then also what we will need, because you see this area ends right here and there's brick over it, what we'll need to do is size a beam to carry that brick as well. So we will need a beam right there. So technically they could support that with a rafter as well, but I just find it easier and probably safer to just design a beam to carry that area. All right. So now we have all our beams drawn in. Oh, I just realized that we're missing an area that doesn't have floor joist called out. This small area here, and then this small area here as well. All right. So make sure that you periodically save your files as well. You don't want all your work to go to waste. So we size all our floors. Now let's do our sections, our porches. So like I said, no one stores anything over porches, so we can use our 1020 load there. All right. Now, next, we'll need to size our beams. So, there's a few beams we need to size. Well, first, I know what we can do. Let's change these. So right now, these still say stud columns, but these are not. These are now no longer stud columns. They're stud columns up above, but on this page, they're not stud columns because they're just point loads from up above that we need to support. So what we'll do is we'll change that to PL, and we'll put this on the floor 1 text layer, or floor 1 notes, and this on the floor 1 engineering layer. Oh, engineering loads layer. I apologize. So what we do is we come over here, we copy our point load all out. I'll just put that right there, that right there. And we can just delete that. And then we can just move it up. There you go. So that's where it should look like. And we'll come and do the same thing over here. there we go. And then we'll just copy this. All right, so we need to draw in our beams with our stud columns as well. Right, and hopefully all these openings are the same size. Oh, that one's a little bigger, but this one should be the same size. Yep. All right, so just move this over, shorten that. All right. Also, I guess we can go ahead and do this now. What we do is we have our generic notes that have our design loads and all of our structural notes and callouts, also with our sheathing notes. So what we'll do is we'll copy those. Those notes go on, structural notes go on all the pages. I typically put them on the foundation page, the first floor page, and the second floor page. I don't typically put it on the roof plan because there's not really, besides the load for what we use for the roof, there's really not any call outs for the roof in particular. Everywhere pretty much is like anchor bolts, concrete, jack studs, all that kind of stuff. So there's not really any call outs on the roof, so I typically don't call anything out there. So all those go on the same page. Also try to put those on all in the same spot as well. And then I do our sheathing notes. Copy that to the same spot as well. Obviously, the foundation plan has no sheathing, so you don't have to worry about that. But the first and second floor plan do. So you got our notes. And in our note number 4, it's pretty much specifies that all load-bearing exterior window headers and interior headers are to be 2 2x10s with 1 jack stud and king studs per code, unless noted otherwise. So basically, what you'll need to do is, when you're first starting out, you'll want to check the headers, the load bearing headers, to make sure that 2 2x10s work. However, I've done this for a long time, and I pretty much know the capacity of a double 2x10 header, especially with a lot of these like door openings and whatnot. They're usually 3 feet or smaller, and for a 3-foot span, 2 2x10s is very strong. So it would take a lot of load or a really big point load on that header in order for a double 2x10 not to work. So that's the reason why. So also, these posts here, they show like round columns. 99.999% of the time, they don't actually use those columns. A lot of times they're just decorative to look good. But what they'll actually use is a 6x6 post and then just kind of wrap it in that decorative look to make it look grand. But it's actually not really, it's actually not really there. So what we'll do is we'll come in here right into the middle of that circle and draw in our columns. All right. So if you notice, now our headers they're not really lining up where our beams are not really lining up with our columns. So what we'll do is we'll just offset them 2 more inches. That way they line up. We'll have to move our columns over, but that's fine. I just use the fillet command right there. So that way I don't have to bring the two together. That command is F, by the way. Or you can come over here and use fillet. There we go. Alright. Alright, and now that that's done, we need to give our connections. So how do we connect the beam to the column itself? We have a generic call out. Basically, pressure treated 6x6 posts with 2 Simpson LCE4Z corner posts at corner posts and 2 Simpson AC6Z at intermediate posts. So I'll show you what these look like. Basically, this is what the LCE looks like at corner posts. The reason why we call that out is because they're really easy to install and they're very strong. Basically, this is what it would look like at the corners. They would just put those there and you're good to go. And then it's also good for £760, so you're good. There you go. And then the AC6Z here, they just collar it like that. Like this. This is what it looks like. Just collars on both sides. And there you go. So that's why we call that out. And that's actually good for if they put the max amount of nails, it's good for 2,800 pounds uplift and 2,000 pounds of lateral loading. So it's actually very strong. And here we'll put the same note, except we'll modify the note because there are no corner posts. There's only one post, so change that from 6x6 posts to 1 6x6 post with 2 Simpson AC6Z. We don't need to say typical because there's only one. All right. So now that's done. Oh, also there's a header right here. It's a really big header, so we'll need a beam there as well. I missed that one. Match properties. All right. Now that that's all done, it's time for us. Well, change that as well. All right. Now it's time for us to size our beams. Let's start with the easiest ones, the porches. So the porch beams, they have this ceiling as well as this part of the roof. So the trib area is the whole area is 6 feet. So from this wall is carrying half of this span, so that's 3 feet of roof and then 3 feet of ceiling as well. So using beam check, well, let's use Forte because I think Forte is probably the best one to illustrate what we're doing here. All right, so our span, typically I size everything based off of max span. So it's 10 feet, 9 foot to 10 feet. So, all right, so let's do 10 feet. Custom. They're 6x6 posts, so it's 5.5 inches. They're not stud walls, they're columns. Southern pine, southern pine. And then it's center to center. And then, so 3 feet of roof, so it's 10 pounds dead load. Delete that, 20 pounds, and it was 3 feet. Technically, we could put all this in the same one, but for clarity's sake, I'll separate the two out. And then 10 pounds dead load, 10 pounds live load for the porches. All right, 10 feet. All right, that's all the loading. Now let's see what we need. Commodity lumber, 2x. Typically, we use two 2x10s for the headers because that's what everything is designed around. That's the most industry standard. It's the most common. So for that look, we size everything 2x10s, and then we'll just select all, see what works. So technically, one 2x10 works. So let's go with two 2x10s. And that loading is 800 pounds in total. So we won't even worry about that. I typically don't for exterior for the porches. Usually the load is so small, unless it's like a very big load. I typically don't worry about it. Calling those out like the rest of these headers. Columns. Copy it. Two 2x10s, typical. That way we don't have to write two 2x10s everywhere. Since we sized it for the worst case scenario, we know two 2x10s works everywhere, and we can just say two 2x10s typical because everywhere is 2x10s. So rather than labeling two 2x10s, two 2x10s, two 2x10s everywhere here, we'll just say typical. It's quicker. Now, so let's go over here. I assume that this will work here as well. 10'7". Let's call it 10'7". So what is this? 7 feet. So slightly bigger. 3.5 feet. This is 10'7". Two 2x10s still works. What do you know? Now it's 1,000 pounds. Still not enough for me to worry about it really. We know that two stud columns works based off of what we sized from over here. That was 1,600 pounds. That isn't even that. This is 1,000 pounds. So we know two stud columns works. And two 2x10 still works everywhere as well. So we're good to go. All right, that size. Now, let's quickly, kind of like we did on the second floor, let's draw in our rectangles. All right, and let's draw in our rectangles where our load-bearing points are. Oh, didn't draw that one right. All right, here we go. All right, so here's all of our load-bearing walls on the inside. And then we'll just match properties, so that way we can put them on. Actually, we don't need to call that one out because this is actually a garage wall. Garages always have a foundation around them, so they're already load-bearing, so you don't need to worry about those. All right. So while we're at it, let's call out all of our loads. So come over here, copy. So from here to here is 23'4". So come back to our calculator. We'll clear everything. 23'4" divided by 2. So that's multiply that times 40, which is for the loading for floor joists. So we got 467 and 583. 467, 583. But you also have to remember the weight of the wall. So 4 times, these are 9-foot walls, remember. So 4 foot times 9 is 36. So plus 36 is 619. So let's round up to 620. All right. Oh, forgot PLF. So let's copy that. Remember, this is all on the engineering loads layer, so no one can see it. Whenever the final product is done, it's just for us in the future. So, and that span 16'6". So we get 16.5 divided by 2, 8.25 times 40, 8.25 times 50, plus 36. We come over here so we can see it. So 330, 449. All right, and then from here to here, this will probably be the biggest span, honestly. 28'2", so 14'1". So 14'1" times 40, 14.1 times 50, plus 36. So we got 563, 740. Right, and then actually let's delete this one because technically these are not the same. Here to here, and from here to here. Well, now we can extend it all the way out. That's fine. It won't bother me. If anything, it's being conservative. All right. So from here to here is 18'10", so that would be 9'5". Well, 9'5" times 50 plus 36. So we got 377, 507. And then from here, got 19 foot 4. So what is that? 19 foot 4, 5 by 2, 6, 9 foot 8. Okay, 9 foot 8 was 40. 9 foot 8, 50 plus 36. 387, 519. All right. And those are all of our interior loads. So usually once I finish that, I go ahead and I copy all of that over. All of this over to the foundation plan. So that way it's already there. We don't need to worry about it. Now, this plan is a little different. The customer actually wanted for a stem wall, which is basically a concrete slab with a regular foundation wall around it. But for this exercise, I'll also do a crawl space option just to show you what it looks like. All right, now that's being copied over. So basically, these are our load bearing points from up above that we need to take into account. All right. All right, now let's get to sizing some beams. So typically, any beam that only has one type of load on it, I'll use beam check. If it has multiple types like roof and ceiling, or roof and floor, or floor and wind, and roof, then I'll use Forte. But for beams that only have one type of load, I'll use beam check because it's just quicker. So let's do that first. So this beam from center to center of the studs is 8 foot 4. So from here, exit columns. So simple span, 8 foot 4, 40, 50. Well, we can just use this loading. Technically, that includes the wall as well, but who cares? We can just do 563, and then 740 minus 36 is 704. So none of these work. 2x14s don't exist, and it says it needs 4 2x12s. But this is a 2x4 wall, which can only have 2 plies max, so it needs an LVL. 2 7 1/4s. 7 1/4s not very common, so always go up to 2 9 1/4s. So it's saying that it needs 2 9 1/4s, and these are our loads. So what I'll do first is copy what the loads are. Because we'll need to know what those are whenever we put them in the foundation. On a stem wall foundation, any point load that's less than, say, on the exterior, 5,000 pounds, don't worry about it. You don't have to put a footing because the existing foundation wall and footing will carry it. Anything less than 3,500 pounds on the inside, don't worry about it because the lug footing will carry it. So 2 9 1/4 inch LVL with 2 stud columns each end. You can go through the exercise of sizing the stud columns on each end if you want. But like we did before previously, 2,900 pounds, 2 stud columns can carry it easily. All right, so that one's done. So let's size this one, shall we? It's 4 feet. 4 feet. And then the trib area is half of that center to this center, which is 17 foot 2. So what's 17 foot 2 divided by 2? 8 foot 7. So 40, 50 times 8 foot 7. There you go. Now, there's such a short span, LVLs will not be required. 2 2x6s works. But because we're using 2x10 floor joists, we'll use 2 2x10s. And there's your loading right there. You don't need to say bottom flush because they're the same size. The easiest thing about this is selecting both of those. This is single line text. You can, if everything has the same values, you can just select both of them and then just come into your quick properties here and change the contents. Right? Found those loads. All right. Now let's come over here to this garage beam. So what is this span? From center to center is 21 foot 10. So one thing to know, anything over 20 feet, you have to change the deflection criteria from 360 240 to 480 360. This was 28 foot 10. And let's see, what is this span? From here to here, 21 foot 8. 21.66666 by 2, 10 foot 10. All right, now let's go over to an LVL. What size LVL will need? 2 20-inch LVLs. It's at 94%. So we could either go up to, we could go to 2 22-inch LVLs, but 22-inch LVLs are not very common. So what we'll do is we'll just go up to 2 24-inch LVLs. And there's your loading right there. Right. One thing about beams that are really long, if with beams that are very long, unlike here where we'll just say with 2 stud columns each end, because you can see the stud columns right with the call out, they won't be missed. But if you say like right here, since this spans all the way here, a lot of times when they're building it, they'll just see the studs, but they won't see any call outs for it and they'll miss it. So what, for really long spans, I typically just call out whatever the beam size is and then actually label what the stud columns will be on each side. So let's see. Seven 30, 48. Yep, that's done. So now we'll need to see 9-foot studs. How many stud columns do we need? I'm thinking 3 or 4. 4. Also, another thing to note, with beams that have really long spans, you'll have to take into account crushing action. So the compressive strength of Southern Pine, um, parallel to the grain, which is basically the top plate and then the beam sitting on top of it, is 565 psi. So basically, what you have to do to figure out what that max load it can take is take that 565. It's a 2x4, so it's 3.5 inches wide, which is what the beam will be sitting on, and then you have to multiply that times however wide. So this is a 2-ply LVL, which an LVL is 1 3/4. A 2-by is 1.5. So 2-ply LVL is 3.5 inches. So you have 3.5 times 3.5. So let's see what that is really quick. So 3.5 times 3.5 is 12.25. So multiply that times 565. The max load that a 2-ply member can take without crushing the top plate is 6,900 pounds. This is at 6148, so we don't have to worry about it. The options to what to do if that is too big, too much for the crushing action, then what you'll need to do is either one, add more plies, which can get more expensive really, or they can use an LVL top plate because an LVL top plate actually uh, is an LVL has 750 psi of crushing action, so either that or they can use like a steel plate. But all right, so we size that. Now, let's see anything else. Let's size this one, shall we? So from here to here is the loading of the brick up above. So this one is a little weird. So that whole span is 10'8", 10.6. All right, so what's loading on it? Not a lot, really. It's just 40, 50 loading just because it's right next to the floor, so it can be used as floor. There's wall up above here. This wall right here. It's an exterior wall. Um, and then there's roof, and that's pretty much it. And then the rest is brick. So we got roof. I know I said before that I like to use Forte when there's multiple types of loading, but for this case, because the loading is so minimal, I don't really worry about it. It's less than 20 feet, so we can use 360/240. And then the wall, which is 8 feet, so 64. I'm being very conservative here because the wall actually is 8 feet the whole way. And then there's brick from 0 to 5'10". Let's just say so brick is actually 40 psf per foot. It's 40 psf, so you multiply that however many feet it is. So let's just say 8 feet because that's how tall that ceiling is. Technically, it's like a triangular loading. Some of it is more, some of it is less, but we'll take into account here. All right, and then, but brick is very brittle, so you have to up the deflection, the total deflection, to L over 600. So let's see if 2-bys will work. 3 2x12s. Yeah, that'll work. But actually, let's not do that since everything else is 2x10s. do 3 9 1/4. You know, the more I think about it, I'm not really sure if I want to do that. Let's come over here to the architectural page. So if you look at here, you can see that they probably won't brick this all the way down. They'll probably brick here. So what we'll do is, and we actually, this is also straight out of the code, but if you look on our detail sheets here, so we actually have a detail for masonry support and what size lintel and, you know, what rafter and all that kind of stuff. So how about this? We'll just come over to the roof. All right, here. And copy this note. Triple rafter, triple rafter. There we go. We'll just do that instead. I think that works good. Now, we don't have to worry about this being support, and we can just make this a double joist underneath the wall for extra support, just in case. And that load is so minimal that we don't need to call out any stud columns. All right, I think that's it. So that's all the interior beams. Now, time to start sizing beams with multiple loads. So let's start with this beam here. So here to here is 12'2". All right, so this is Southern Pine, everything's stud walls. All right, so let's start with our loading. So we have from here to here 5 feet of floor. So half of that is 2'6". 10, 40. All right, that's our floor. Copy that. And then here is ceiling, but remember, we decided to make that light storage just for safety's sake. So half of 6'10" should be, I don't know what that is. 3'5". There you go. Yeah, I should know that. 10, 20. Okay, it's on the back side. And then we've got our roof load, which is 355 and 533. So change that to a PLF since we've already calculated what it is, 355. And then what was that, 533? Yeah, so 355 minus 533, 78. 178 dead load. That'll be on top. So those are our 3 loads. So this is ceiling, and this is roof. All right, see what it needs to be. I can guarantee you right now that a 2x won't work, but we can try it. So 9 1/4, 11 1/4, and 11 7/8. Select only ones that work. Yep. See, no 2x's work at all. So you can use 3 9 1/4, or we can use 2 11 7/8. The 11 1/4 is not very common, so just go with the 11 7/8 because 2 is cheaper than 3. All right, so 2 11 7/8 inch LVL. So here we will need to call out bottom flush because it's bigger than the joist. 2x10s and 2x6. So basically they have to install the bottom of it with the bottom of the ceiling joist so it doesn't stick down. And remember our load cases calc that we had for the roof? We'll have that same calc for here. All right, so our dead load, 1517, 1024 live load, and 2160 for roof. So this is our total loading here. So I believe 3 stud columns will work here. Two actually, but yeah, let's go with 3. All right, that beam sized. We'll size these last. Let's size this one, shall we? 18'4". Since this is a header, we'll size it this way. 18-foot garage door. Let's put 3 inches because 2 studs. Right, our loads. So 11'8". 5'10". Right. Our roof load. There's no load on the second floor because this is all attaching to the roof. So let's just come over here to the roof load. Let's call it 22 feet. 11, 20. All right, that's a roof. Now, there's also brick veneer on this as well, so we'll have to see if there's brick above that garage. So Nope, they show siding above the garage, so we're good to go. We don't have to add brick load to it. All right, that's it. Let's see what size LVL we need. 2 14s, but it deflects 0.866 inches. Another thing to note, you never want your deflection to be more than 0.75 inches. So let's go with 2 16-inch LVLs.